So these are the equation I have written. So you are telling me which one is linear according to the definition, which is a three-step definition. So first equation is dy by dx. So dy by dx, let me write y raised to power 0 here. So the derivative first order, its exponent is 1. So degree 1, and if any dependent variable is present, its exponent must be 0 or 1. So it is linear. So look at the second. Since the first order derivative having degree 1, power 1, so the degree 1 is linear, but you have to follow the other two steps of the definition. Dependent variable is y and its exponent is 2, so 2 is not allowed. It should be 1, so non-linear. Coming to this, here y raised to power 5 make it non-linear. Here in this case y square root mean y raised to power half. Power is half. Half is not allowed. It should be 1 or 0. Similarly, coming to there, the first order derivative, its exponent 1 to degree 1. And if any other derivative or dependent present, their exponent must be either 1 or 0. So its power is 1, its power is 1. So this is linear. Coming to here. So y dash plus x over y. If you are taking this y here, multiplying by y, so the dependent variable and the derivative both multiplied. So this is non-linear. Or if you can take y on the numerator, so raised to power minus 1, that is going to be the same. Here y dash is equal to sin x y plus ex. Or here is this. So what is the difference between these two? One is linear, one is non-linear. Non-linear and this is linear. Let me have sin x. If I am writing sin x using Maclaurin series, this is x cube divided by 3 factorial plus x5 divided by 5 factorial minus x7 divided by 7 factorial and so forth. This is the Maclaurin series for sin x. If I am replacing x by y, so this become y minus y cube divided by 3 factorial plus y5 divided by 5 factorial, y7 divided by 7 factorial and so forth. Here x dy by dx, x is independent variable. If you are replacing sin x by this series, so x is your independent variable no matter how large your x is. Y exponent is 1. So this is linear. Here you are sin y, you are writing in terms of Maclaurin. So y is your dependent variable. Dependent variable must not be more than 1. So here y cube, y5, y7, if you are writing this Maclaurin series there, so this is non-linear. Similarly, if you are writing y dash is equal to ex, or you are writing y dash is ey, one of them is non-linear, which is ey. Because if you are expanding this in Maclaurin series, this is 1 plus x square divided by 2 factorial plus x cube divided by 3 factorial and so forth. So your x is independent variable no matter how large your x is. One more is very important definition. So related to the degree of the differential equation. The degree of the differential equation is the exponent mean power of the highest order derivative This is the case I have written in a minute before. The degree is the differential equation is the highest order derivative, the exponent. After the equation, this is really important concept because after the equation has been made free from radicals or fractions in its derivatives. Look, this is very important concept. So the degree is going to be exponent of the highest order derivative, but if your differential equation containing the derivative are under the radical sign or the derivative are in fractions, so how to define the degree in this case? So you have to have after the equation has been made free from radicals. For example, let me have 1 plus y dash raised to the power half is equal to y double dash. This is the differential equation because it contains derivative. So what is the order, what is the degree? In this case, how would you define degree? You are not going to have the exponent of the highest order derivative because here the derivative is under the radical sign. So in this case, you have to remove the radical sign, squaring both sides. Squaring both sides, we are getting 1 plus y dash is equal to y double dash whole square. Now the derivative is removed, the radical sign under root is removed by taking square of both sides. This is the differential equation you are having. So what will be the degree in this case? The degree is 2 this time. This is really important. So you should work on it. Degree is 2 this time. And if I am going to have one more example, which you are going to be y double dash plus y is equal to x y under root. What will be the degree? What will be the degree in this case? The degree is 1. So see the difference. So after the equation has been made free from radicals or fraction, its derivative. Look, this is important. Derivative. If the derivative are under the radical sign, you have to remove. But since the dependent variable is under the radical sign, do not get it removed. So what you are going, you have straight away write down the degree. So the degree is 1 this time, highest order derivative exponent. Let me have 1 or 2 example more related to this so that you can have the degree. Y double dash whole square is 1 plus y dash cube. One more, d cube y by dx cube under root raised to cube root of third derivative is y dash. For example, I have 2 equations. What will be the degree in this differential equation which I have written? The highest order derivative is 2, its exponent is 2. So the degree is 2. Degree is 2 because this is not the fraction, this is not the radical sign, it's a positive integer, that's okay. But if something radical sign or fraction, then you have to. Look here in this case. In this case, the equation is going to be triple dash raised to the power 1 by 3 is y dash. Look. So under the radical sign, the derivative is there. Y triple dash is 1 by 3 y dash. What will be the degree? You have to take cube of both sides. Taking cube of both the side. Cube of both the side. This cancelled. So you are left with y triple dash is y dash whole cube. What will be the degree here? Highest order derivative is third order, its exponent is 1. So degree is 1 in this case. So if a differential equation having derivative under the radical sign, before telling the degree you have to remove the radical sign. Let me have couple of follow-up. Find the order, degree of the following differential equation. Also state whether linear or non-linear. So this you have. Number 1, y double dash plus 3y dash plus 4y equal to 0. You have to write down the order, the degree, and telling me whether it's linear or non-linear. X square y double dash plus xy dash plus 3y is equal to 5x. 1 plus 2x square, square root of that. 1 plus 2y square dy equal to 0. Fourth, 1 plus y dash whole square raised to the power half is equal to x square plus y. Then fifth is y double dash plus t square y dash plus 4y is cos t. Fifth is this, and sixth is y double dash whole square plus 3y dash plus x equal to 0. Seventh is y dash y double dash plus y dash plus 5y equal to sin x. 8 is 1 plus y dash raised to the power half is y double dash, and 9 is y dash is sin y. So these are the differential equation I have written. You are telling me the order, the degree, whether linear or non-linear. For example, highest order derivative. Second order, its exponent is 1. Order 2, degree 1. And linear, because this first order derivative have exponent 1, this dependent variable have exponent 1, here dependent variable is not there, that's okay. So this is order 2, degree 1 and linear. Similarly here, derivative is under the radical sign, remove it and telling me. Here order 2, look at that. Highest order derivative, second order derivative, exponent is 1. That is first step of the linear if degree 1. So again, this dependent variable is multiplied with the derivative. So dependent variable should not be multiplied. So order 2, degree 1 and non-linear because this y is multiplied. Similarly, 2 derivative here, look at that. Order 2, degree 1, that's okay. But this one of the derivative is multiplied with the double derivative. So non-linear. Here order 2, degree 2. If degree 2, you are not proceeding the next 2 steps. Because if degree 1, then you have to look at the 2 steps of the definition. But here degree 2, order 2, degree 2, non-linear. Here coming to this point, y dash is equal to sin y. Order 1, degree 1 and non-linear, because if you are expanding this using Maclaurin series, so y is going to be increasing and increasing and increasing.